February 14th, 1945, Roer River Valley, Western Germany. The morning mist had frozen to the barrels of the tanks waiting behind the low hedgerows near Linnich. Inside the turret of an American M36 Jackson tank destroyer, Sergeant William McGowan sat hunched beside the long, black steel of his 90mm gun. His breath fogged the eyepiece of the M83 telescope as he watched the far tree line through a slit of vision no wider than a playing card. Somewhere ahead, across 2,000 yards of churned farmland, a German Tiger had just fired its first shot. The sound reached them like a door slamming in the distance, followed seconds later by a column of earth 50 feet high. The shockwave rattled the turret. McGowan didn't flinch. He whispered to his gunner, "Range, 2,000. The loader rammed a 38-pound armor-piercing round into the breech. The smell of oil and brass filled the turret. The gun recoiled like a living thing, sending the empty shell clattering against the turret wall. Through the scope, McGowan saw a flash, then smoke, then nothing. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you." When they advanced that afternoon, the Tiger lay on its side, turret torn open like a peeled can. The American shell had struck through 2 inches of front armor from a distance that most German gunners considered impossible. The 90mm M3 gun had done what the Germans' own vaunted 88 could rarely do at that range: kill a Tiger before it could return fire. This was the moment American crews began to realize that the myths they had grown up hearing about German invincibility, about Tigers that could shrug off anything, were just that, myths. But to understand how this moment came to be, we have to go back not to the battlefield, but to the philosophy that shaped it. In the early years of the war, German tank doctrine rested on a sacred belief that quality would always overcome quantity. From the very beginning of Blitzkrieg in 1939, the Wehrmacht's armoured arm had been built not only around superior tactics, but also around an engineering faith, the idea that perfect craftsmanship, in steel and optics, would make their tanks unstoppable. German officers studied the science of gunnery as if it were theology. The Tiger's 88mm Quebec 36 cannon, adapted from the famous 88 anti-aircraft gun, could penetrate roughly 110 millimeters of armor at 1,000 yards, a figure that dwarfed most Allied weapons of the time. German firing tables, meticulously logged in the proving grounds at Kummersdorf, recorded dispersion patterns and armor slope calculations down to fractions of a degree. It was precision engineering elevated to doctrine. To the Germans, range was power, and the Tiger was the embodiment of that power. For the Americans who would one day face it, the Tiger was almost mythical. Intelligence bulletins circulated among U.S. units in North Africa and Italy warned that the German heavy tank's front armor was impervious to all known Allied weapons except the high-velocity 75mm gun of the British Firefly. Infantrymen told each other stories of Shermans whose shells bounced harmlessly off the Tiger's thick hides. By late 1943, this legend had hardened into fear. American tankers in Italy learned to call air support rather than face a Tiger head-on. The Sherman's 75mm gun, with its relatively low muzzle velocity of 2,000 feet per second, could not penetrate the Tiger's frontal armor beyond 500 yards. It wasn't just a technical gap, it was psychological. American crews believed that German tanks were built by men who understood war better, who had somehow distilled experience into steel. German gunners were trained to believe the same, that their optics, their Zeiss rangefinders, and their perfectly machined breeches made them invincible. Yet, as the war dragged into 1944, German doctrine began to ossify. The Tiger and Panther were masterpieces, but they were also heavy, slow to produce, and built for an industrial base already collapsing under Allied bombing. Each Tiger required over 300,000 man-hours to build, and consumed quantities of tungsten and chromium Germany could scarcely replace. In the same months that German engineers were perfecting their armor slopes, American factories were perfecting something else: production efficiency. The Chrysler Tank Arsenal in Warren, Michigan, rolled out M4 A3 Shermans, at a pace of nearly 20 per day. The Ford plant in Detroit built complete tank engines on the same assembly lines once used for automobiles. But quietly, in parallel, American ordnance engineers were working on something the Germans never anticipated, a gun designed not as a derivative of an old artillery piece, but as a system, meant to exploit the full range of industrial precision the United States could bring to bear. The 90mm M3 gun was not born in a laboratory. It was forged in the tension between battlefield necessity and American manufacturing ingenuity. In 1942, the U.S. Army's Ordnance Department had already been developing a 90mm anti-aircraft gun, the M1, capable of firing a 24-pound projectile at nearly 3,000 feet per second. Engineers at Aberdeen Proving Ground recognized its potential for anti-tank use. The challenge lay in transforming a weapon designed to fire skyward into one that could fit inside the cramped turret of a tank destroyer. What emerged was the M3 variant, a slightly shortened barrel, fitted with a horizontal sliding breech block and designed for the new M36, and later the M26 Pershing. It fired the same 90mm shell as the anti-aircraft gun, but used a modified propellant charge. At standard service pressure, the gun could penetrate 160mm of homogeneous armor at 1,000 yards with the M82 armor-piercing capped projectile. With the new T-33 high-velocity round introduced in early 1945, penetration extended beyond 2,000 yards. But numbers alone don't tell the story. What mattered was how it felt the shift in confidence. Tank crews who had grown used to being prey now realized they could strike first. In after-action reports from the Ruhr and Rhine crossings, tank destroyer battalions equipped with the 90mm reported confirmed kills on Tigers and Panthers at ranges previously thought suicidal. The official report of the 703rd Tank Destroyer Battalion near Cologne records one such event. Engaged Panther at range estimated 2,000 yards. First round hit, penetration through mantlet, tank burned. This was not chance. It was engineering meeting doctrine. For years, German officers had believed their 88 gave them dominance at range. Yet the American 90mm, with slightly higher muzzle velocity and superior high-explosive performance, was being mass-produced with tolerances that guaranteed consistency shot after shot. The German gunners, by contrast, were working with weapons whose supply chains had begun to break down optical lenses with impurities, propellant lots with inconsistent burn rates, barrels worn out by overuse. The irony was profound. The nation that had once defined itself by mechanical precision was losing the precision war not because of design flaws, but because of exhaustion. By the winter of 1944, Germany could no longer produce the materials needed to maintain the quality of its once perfect weapons. Tungsten shortages forced the substitution of inferior core materials in armor-piercing rounds. Barrel life on the 88 dropped. Even optics, the sacred glass of German marksmanship, began to blur, literally, as the quality of polishing compounds declined. Meanwhile, in America, the opposite was happening. The Allegheny Ludlam Steel Company in Pennsylvania produced chrome-molybdenum alloys with exacting chemical balance. General Electric fabricated precision lead-screw mechanisms for the gun's elevation controls. Every component was standardized, interchangeable from one gun to another, a concept the Germans had never fully embraced. What emerged was more than a weapon. It was a demonstration of what an industrial democracy could produce when its engineers and machinists were given resources without constraint. The 90mm gun was never meant to be a symbol. Yet by 1945, it had become exactly that, the proof that America could meet Germany not only in numbers but in quality, and exceed it. The first time a German crew inside a Tiger realized this, it wasn't through a report or an intelligence bulletin. It was through the sound, the sharp crack of a 90mm shell hitting home from beyond the range they thought possible. For them, it was the sound of disbelief. For the Americans, it was the sound of vindication. February 14th, 1945. Roer River Valley, Western Germany. The night frost still clung to the barrels of the tanks hidden behind the hedgerows outside Linnich. Inside the turret of an American M36 Jackson tank destroyer, Sergeant William McGowan rubbed the condensation from his periscope. Somewhere across 2,000 yards of frozen farmland, a German Tiger had just fired its first round. The blast echoed like distant thunder, followed by a column of dirt erupting behind the American line. McGowan's loader already had a shell in hand, 38 pounds of steel, copper, and propellant. Range 2,000. The breech locked. A concussion, a flash, the metallic crash of the spent casing. Through the haze, McGowan saw smoke blooming from the Tiger's flank. Hours later, they found it burned out, turret split open. One round. A kill at a distance the Germans had once thought beyond the reach of any Allied gun. That morning marked a quiet turning point. For months, German propaganda had promised that no Allied tank gun could pierce a Tiger's armor beyond 500 yards. Now, crews like McGowan's were learning that the myth no longer held. The 90mm M3 gun, an American weapon born from anti-aircraft experiments, had rewritten the mathematics of armor and fear, the faith in steel. To understand what shattered on that field, one must begin with belief. German armored doctrine between 1939 and 1943 was more than tactics. It was theology. The Tiger Eye was its altarpiece. Its 88mm Queb 36 gun, derived from the revered Flak 88, could pierce 110mm of armor at 1,000 yards. Its optics, crafted by Zeiss and Leitz, were unequaled in clarity. In the manuals issued by the Heereswaffenamt, German crews were told that marksmanship, not volume, won battles. Each shot was to be a statement of precision, not probability. American tankers saw the results in Tunisia and Italy. Reports from the 1st Armored Division described shells from Sherman's 75mm guns glancing off the Tiger's glacis, like stones against a cathedral wall. In the early winter of 1943, an intelligence memo circulated through the U.S. Army Ordnance Department. Current tank armament insufficient against heavy German types. Immediate investigation into higher velocity weapon required. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story. That memo reached the engineers at Aberdeen proving ground. They already possessed a weapon with the necessary velocity, the 90mm M1 anti-aircraft gun, firing a 24-pound shell at nearly 3,000 feet per second. If it could reach bombers at 30,000 feet, perhaps it could reach a Tiger across 2,000 yards of open ground. The American approach. Unlike German engineers, who prized perfection at any cost, American ordnance officers designed for repetition. Every gun had to be reproducible by the thousand, serviceable in the field, and compatible with existing manufacturing tools. At Watervliet, Arsenal and General Electric's Lynn plant, draftsmen shortened the anti-aircraft barrel, adopted a horizontal sliding breech, and rebalanced the recoil system. The result, standardized in 1943 as the M3 gun, could fit inside a turret and still throw a 38-pound armor-piercing shell at 2,700 feet per second. Mounted first on the M36 tank destroyer and later on the M26 Pershing, it transformed American armor from reactive to aggressive. Penetration trials at Aberdeen showed that the M82 APC round could defeat 160mm of homogeneous armor at 1,000 yards. The improved T-33 round, issued in limited numbers in 1945, extended that reach to roughly 2,000 yards, a range at which the Tiger's own Queb 36 could seldom guarantee penetration of a Pershing's frontal plate. The psychology of range was more than a number on a chart. It defined confidence. German crews trained to believe that superiority meant distance, see first, fire first, kill first. But as the war ground on, their advantage eroded. Fuel shortages limited live-fire practice. Barrel wear from relentless Eastern Front fighting reduced accuracy. By late 1944, tungsten for high-performance PZGR 40 rounds was almost gone. Crews were issued standard steel-cored shells that shattered against Allied armor at ranges where earlier ammunition had pierced clean through. In contrast, the American logistical system guaranteed uniformity. Each 90mm shell left the plant inspected by multiple gauges. The same propellant formulation fired in Italy, in the Ardennes, and on the Rhine. Crews could trust that when they dialed 2,000 yards, the round would land where physics said it should. The industrial irony, here lay the great wartime irony. The nation that worshipped precision lost it through scarcity. The nation that mass-produced everything achieved precision through abundance. German gunners began to complain of blurred optics and inconsistent ammunition lots. American reports, by contrast, noted minimal variance between guns assembled on opposite sides of the country. Standardization had become a weapon of its own. Every component of the M3 gun, from its forged monoblock barrel to its hydro spring recuperator, could be swapped in the field without custom fitting. A German K88 required factory-level alignment to replace a recoil cylinder. An American ordnance crew could do the equivalent job roadside with wrenches and a manual. A shift in doctrine. When the 90mm reached frontline units in the autumn of 1944, doctrine shifted. Tank destroyer battalions, such as the 703rd and 601st, were instructed not merely to ambush, but to engage at long range. Gunnery exercises emphasized first-shot kills beyond 1,500 yards. Reports from the Ardennes recorded multiple Panthers destroyed before they could return effective fire. One after-action statement from the 703rd near Cologne reads, "Engaged enemy Panther at estimated range 2,000 yards. First hit through mantlet, tank burned." It was a sentence impossible to imagine a year earlier. By the time McGowan's M36 fired across the Roer Valley, the myth of the invincible tiger was already cracking. The 90mm gun was not just another piece of equipment, it was the physical manifestation of an industrial democracy, learning how to match and surpass the craftsmanship of an autocracy. When that shell crossed 2,000 yards and tore open the tiger's armor, it carried with it more than kinetic energy. It carried the weight of an idea that the war of machines would not be won by the most beautiful machine, but by the system that could build, feed, and fuel it endlessly. The proof on the battlefield. The first decisive field test of the 90mm gun came with the 703rd Tank Destroyer Battalion attached to the 3rd Armoured Division during the push toward Cologne. Reports from the unit's after-action log on February 26 read, "Enemy armor sighted at 1,800 yards, believed Panther type. First round, armor-piercing capped, struck turret face, complete penetration. Second round set tank ablaze. Photographs taken 2 days later by Signal Corps correspondents show the result, a Panther, its turret ring split and gun drooping toward the earth, its armor punctured clean through. These images would be studied for months afterward by ordnance officers trying to quantify what crews already knew instinctively. The 90mm M3 had altered the arithmetic of survival. German reports confirm the shock. A surviving radio intercept from the 5th Panzer Army's log recorded, "Enemy heavy anti-tank gun of unknown type penetrates front of Panther at great distance. Armor, ineffective. Recommend engagement only under 1,000 meters." The recommendation came too late. At the Rhine crossings in March 1945, tank destroyers positioned on elevated ground engaged German armor, attempting to counterattack across the open plains. The range tables from the 630th Tank Destroyer Battalion document confirmed kills at 1,900 and 2,300 yards, ranges at which German doctrine assumed immunity. The collapse of the Tiger myth. For nearly 3 years, the collapse of the Tiger myth. Tiger had symbolized more than hardware. It was the embodiment of the German claim to technological destiny. Its destruction by a weapon the Germans had dismissed as industrial improvisation carried psychological weight far beyond the battlefield. Captured diaries from panzer crews during the retreat across the Ruhr reveal the shift. Unteroffizier Karl-Heinz Wagner of the 506th Heavy Tank Battalion wrote on March 18th, "The enemy shoots from distances where we cannot reply. Their shells strike true even at 2 kilometers. We no longer feel masters of the field. The numbers supported Wagner's despair. Allied ordnance testing after the war showed that the American M82 round from the 90mm could defeat the Tiger Eye's 80mm front armor at ranges up to 2,100 yards under ideal conditions. Even the later Tiger II, with 150mm of sloped armor, was vulnerable under 2,000 yards when struck by the improved T-33 shot. For German gunners trained to calculate the safe approach distance, these results were incomprehensible. The geometry of their survival, so carefully taught at Paderborn and Putlos, had inverted. The very parameters that once defined superiority had turned into limitations. Inside the American turret, to the Americans manning those guns, the change felt tangible. Crews who had spent years relying on maneuver and numbers now trusted their weapon. Sergeant McGowan later described in an after-action interview preserved in the Ordnance Museum archives. For once we didn't have to circle behind them. We could stand off and punch right through. You could feel it through the turret, the confidence. The 90mm ballistic characteristics gave them that confidence. Its projectile left the muzzle at nearly 2,800 feet per second, maintaining velocity more efficiently than the German 8-8 due to a more aerodynamic cap design. The American shell's weight, almost 40% greater than the German, delivered higher kinetic energy on impact despite similar velocities. When fired with the high-velocity AP ammunition, the gun generated over 7 million foot-pounds of energy at the muzzle, a figure that rendered most wartime armor calculations obsolete. But these statistics mattered only because they were reproducible. Every M3 gun came off the line within a tolerance of less than 1/1000th of an inch in bore concentricity. German production, hampered by material shortages and bombing, could not match that consistency by 1945. The human consequence. For German crews, the material failures translated directly into psychological ones. The Panther's high-velocity 75 could still kill any Sherman it hit, but fuel shortages left tanks immobilized, while inconsistent ammunition made long-range gunnery guesswork. Allied after-action interrogations reveal recurring phrases: "Our shots fell short," "optics unsteady," "barrel worn." By contrast, American maintenance schedules dictated barrel replacement after a fixed number of rounds, ensuring that accuracy remained constant. Every tank destroyer carried a complete field tool kit, torque wrenches, and spare recoil seals, logistics mundane but decisive. The victory of the 90mm was not only ballistic, it was procedural. The turning of doctrine. In April 1945, during the capture of Cologne, a single M36 Pershing, equipped with the 90mm, engaged a Panther at approximately 800 yards on the city's main avenue. The gunner fired once. The shell entered below the gun mantlet and detonated the ammunition rack. The encounter, captured on film by Army cameraman Jim Bates, became one of the most analyzed sequences of tank warfare in history. The footage showed in seconds what thousands of reports had implied. The technological equilibrium had shifted. German armor, once the terror of the battlefield, had become targets in an environment dominated by Allied observation and firepower. The aftermath. By the war's end, the United States had produced more than 7,000 90mm guns in various mounts, anti-aircraft, tank destroyer, and heavy tank configurations. They formed the lineage that would evolve into the post-war M36 and the Korean-era M41 guns. German heavy tank production, by contrast, had collapsed under air raids and raw material shortages. Fewer than 1,800 Tiger I and Tiger II tanks were ever built, many lost to mechanical failure before reaching combat. Post-war evaluations by both American and British ordnance boards confirmed what the battlefield had already proved. The M3 gun offered roughly 10% greater penetration and 15% better accuracy at range than the German 88 when both fired their best available ammunition. Yet the true difference lay in philosophy. The German army had placed its faith in singular machines, complex, exquisite, but unsustainable. The Americans placed theirs in systems, standardized parts, logistics networks, and the belief that reliability was a weapon in itself. The cost of truth. When German gunners first realized that their armor was no longer impregnable, the revelation carried a moral weight. The promise of invincibility repeated in propaganda reels and training halls had sustained them through years of retreat. Its collapse mirrored the collapse of the Reich itself. For American crews, the truth brought no triumphal celebration, only a grim recognition. Sergeant McGowan's final log entry in April 1945, found in the National Archives, reads simply: "Gun performed as designed. Enemy tanks destroyed at long range. Crew intact." Beneath it, in smaller handwriting, a line added later by another hand: "War ended before we had to prove it again." Legacy. In the years after the war, ordnance officers studying captured German equipment noted the irony that both nations had reached similar ballistic solutions from opposite directions. The German Quev 43 of the Tiger II and the American M3 of the Pershing shared comparable muzzle energies and ranges. What separated them was the context of their creation. The KKK 43 was the last gasp of a resource-starved industry seeking perfection in isolation. The M3 was the product of a cooperative economy harnessing thousands of workers who might never see a battlefield but whose labor ensured that every shell, every breech, every recoil spring behaved exactly as predicted. The 90mm gun's success did not end the war. Air power, logistics, and sheer manpower did that, but it marked the moment when industrial democracy proved it could match the mechanical genius of dictatorship on its own terms. By 1945, the myth of the invincible German tank had been replaced by a new understanding that in modern war, precision is not born from artisanship alone, but from organization, planning, and relentless standardization. On the fields near Linnich, where McGowan's crew fired that first 2,000-yard shot, the farmland has long since healed. Only fragments of armor remain, unearthed occasionally by plows. The impact crater where the Tiger fell has filled with rainwater and reeds. Standing there today, one might imagine the sound that once rolled across that valley, the deep, singular thunder of a 90mm shell leaving its barrel. It was more than the sound of steel against steel. It was the sound of an idea that the outcome of a global war could hinge not on myth, but on method. And in that moment, 2,000 yards away, the world learned that precision itself had changed sides. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.